Hey guys, so this is 11.4 part 2. So we're talking about geometric series. So just like with arithmetic series, we can find ourselves a formula for the sum of a geometric series. So to write out a geometric series, it would look like this, right? We're just multiplying by some common ratio each time. With the last term, we're going to have r to the n minus 1 times a1. So let's multiply everything by r. We multiply everything by r, so we have rs on this side, and then we have r a1, r squared a1, so on and so forth. The last term is now r to the n a1. And we're going to take this equation and we're going to subtract this equation. So on this side, we get 1 minus rs, right? And then on this side, there's nothing we can combine with this term. But here we say we have ra1 minus ra1, r squared a1 minus r squared a1. So these cancel. There's an invisible term here that matches this one, so we can cancel that out. There's also an invisible term here that matches this one, because if I went one term back from r to the n a1, I would get r to the n minus 1 a1. So that would cancel here. There's nothing I can cancel with this one. So what I'm left with once I've done this subtraction is a1 minus r to the n a1. So that's what we have here. And then I'm just going to factor out an a1 because I can do that and divide by 1 minus r. So that is going to give us this formula. Note that r is not equal to 1 because if I did that, then I would have 0 down here, which I can't do. But another reason for r to not be 1 is that would be boring. Because then it would never change, right? It would be the exact same number each time, and I wouldn't even need this fancy formula to do that summation. So I don't need r to be able to equal 1, so it's fine that that gets excluded because that would be boring anyway. So that's our formula for the sum of n terms of a geometric series. So let's look at using it. So here we're given that there are 11 terms. This 11 here is telling us that there are 11 terms in this series. So again, for this formula, we need to know the first term, we need to know the common ratio, and we need to know the number of terms. Those are the three pieces that we need to know for geometric series. So we don't need to actually know the last term like we did with arithmetic series. We just need to know what the common ratio is. Okay, so in this first one, the first term is 8, n is 11, and we just need to figure out what r is. Because this is switching back and forth from positive to negative, we know that r has to be negative. And we can see that it would be negative a half. If you don't see that it's negative a half, you can always take this term divided by this term, or this term divided by this term, doesn't matter. And we get that r is negative a half. And then we can just plug those three pieces of information into our formula. So a1 is 8, r is negative a half, and n is 11. Plug that into a calculator and you get 5.336. So, oh, right, there's a part B. And so here, if we use summation notation, again, our n is, since we're starting at 1, n is just going to be 6, so that's easy. To find a1, we just need to plug in 1, right? Plug in 1 for k. So that's just going to be 3 times 2 to the 1, which is just 3 times 2, which is 6. So A1 is 6, and then to find R, that's just going to be the thing that has the exponent. So the 2 has the exponent, so R is 2. If you're not sure, you can always find the second term. So we already found the first term, it was 6. You can find the second term. So plug in 2 here, you get 2 squared is 4, times 3 is 12, and then do 12 divided by 6. 12 divided by 6 is 2, so 2 is your common ratio. If you're not sure, if you're looking at the formula and you're like, I'm just not sure, then you can always find the second term in order to find R. But R is this part of the explicit formula that we learned back in the last section. So, yeah. So plugging those pieces of information in, we have the first term was 6, R is 2, and we had 6 terms. And so this is our sum. And then I do want to talk about this word problem. So at a new job, an employee's starting salary is $26,750. He receives an 1.6% annual raise. Find his total earnings at the end of 5 years. So we want the sum after 5 years. So n is going to be 5. We're given the starting amount, so that's going to be our A1. That goes here. The trick with this is R, right? So if you think of this as being like a exponential formula, hopefully it makes sense that R is going to be the percent, write that as a decimal, and then add 1, just like we did with exponential growth, right? Because it's a raise, it's increasing. So you're going to find your R just like you would with exponential growth or decay for geometric series. So write this as a decimal, 0.016, and add 1. So 1 plus 0.016 is 1.016, so that's going to be our R. Putting all that information into the formula, we get this number. So that's the main thing I want to point out here is the adding 1 when you're finding R. So if it's increasing, you add 1. If it's decreasing, it'll be 1 minus the percentage, right? And make sure you're writing that percentage as a decimal, because otherwise it's not going to work out, right? Okay, let's talk about infinite series. So infinite series in summation notation, you'll see an infinity sign here, and then you'll know you have an infinite series. If the common ratio, right, if R is between -1 and 1, then we can actually find the sum. Now this is not even a geometric series. This is an arithmetic series, so it's not going to have a finite sum. If we tried to find the sum of this, it would be infinite. We can't do it. But if it's geometric and R is between -1 and 1, then we can find an actual summation for this, and that is because the number is getting smaller and smaller and smaller and smaller, right? If R is between -1 and 1, and I'm multiplying something by that each time, my number is going to be getting smaller and smaller and smaller. So it's going to what we call converge, right? It's going to converge on a specific number. In all other cases, it will diverge. So it will diverge, and that means that we're not getting closer and closer to one number. In other words, we're going off to infinity. We can't find a finite sum to an infinite series if it's not geometric and has a common ratio between -1 and 1. We need both of those things. So looking at that, can I find infinite can I find finite sums for these infinite series? Well, first of all, I need to figure out what my common ratio is, because that will tell me both things. It will tell me if it's between -1 and 1, and it will also tell me if this is geometric. So I can't just assume this is going to be geometric. So I'm going to have to find both ratios. So I do 8 divided by 12 and 4 divided by 8. When I do 8 divided by 12, I get 2/3. When I do 4 divided by 8, I get 1/2. Those are not the same. Therefore, this is not geometric, which means I can't find the sum because it's not even geometric. There's nothing I can do. So even though 2/3 and 1/2 are both less than 1, it doesn't help me because they're not the same. So it's not geometric. For this one, it is, if we do 1/2 divided by 3/4, we get 2/3. If we do 1/3 divided by 1/2, we get 2/3. So this is in fact geometric, and it has a common ratio of 2/3, which is less than 1, which means that we can in fact find a sum for this infinite series. For this one, r is 1/3. We know that it's geometric because this is the correct form for an explicit formula of a geometric series. And r is 1/3, so it's less than 1, which means the sum of this one is defined. So I could actually find a sum for this one. This one's arithmetic, so there's no sum for that. Yep, continuing on. All right, so let's talk about how we find a sum. So if the sum is defined, how do we find it? Well, first of all, r is less than 1. We know that, or it's between -1 and 1, right? So absolute value of r is less than 1. So what happens to r to the n as n goes to infinity if r is less than 1? So as a thought experiment, they said, okay, well, what if we take 1/2 and make the power bigger and bigger and bigger? You can see that this is clearly getting closer and closer to 0, right? I have 1 over a very big number. And that's always going to happen. If r is less than 1, you're always going to be getting closer and closer and closer and closer to 0 as the exponent gets bigger. So as n goes to infinity, r to the n is going to 0. So then what is 1 minus r to the n going to? Well, 1 minus 0 is just 1. So this part right here is just getting closer and closer and closer to 1, which means that we can just say the numerator is just getting closer and closer to a1, right? a1 times 1 is just a1. So we can simplify the formula down to this. The denominator didn't change. The numerator is now just a1. This only works, remember, if r is between -1 and 1 and the series is geometric. If either of those things are not true, then we can't use this formula. This formula would give us a number, it would just be wrong. So both of those conditions have to be met before we can use this formula. So looking at that, this series is not geometric, so we can't use the formula. Note again that we could, well, except for we can't find an r for this one because this is not geometric. So yeah, so we couldn't use the formula on this one. We could use the formula on this one, but it would be wrong because r is greater than 1. R is greater than 1 here. So if I tried to use this formula, I would get a number because I have an r here, and I could find my first term, right? So I would get a number. It would just be wrong because r is greater than 1. For this one, we can find an r. This is in fact geometric. R is 0.4. And so I could plug that in. And so I plug in the first term, plug in r, and this would be my sum. So if you think about it, if I tried to add these up by hand, right, if I found more terms and tried to add these up by hand, I can't physically add infinite number of terms, but the more terms I add, the closer and closer I would get to this number. And if I could add an infinite number of terms together, I would eventually get this number. You can't physically do that, but this is the number you would get if you could, right? So then with this one, we could do the same thing. Find our first term. So you plug in 1 here. 1 minus 1 is 0. So the first term is just this number here. And then r is negative 1/3, which is less than 1. So I'm allowed to do this. Plug in those numbers, and this would be the sum that I'm approaching. And I'm pretty sure that's all I have to say. Yep. Okay. Yeah, so that's it for this, for 11.4. Let me know if you have any questions. Yeah, hopefully this has been helpful.